Okay, now we're going to study about correlation analysis. So what is correlation analysis? It is one of statistical technique that we can use to measure the relationship and strength of the relationship between two variables. So normally the two variables are independent variable X and dependent variable Y. So here, in determining which variable is dependent and which variable is independent is a very important step in correlation analysis as well as later on in regression analysis. Okay, now look at what is independent and dependent variable. So independent variable, normally what we change it, and dependent variable, what we observe or what are the outcomes or the outputs. So here I put control variable. So what is control variable? So that is variable that we keep the same. So for your level, diploma level, we just focus on independent variable and dependent variable only. Okay, now look at example here in determining on how to determine which one is Y dependent and which one is independent variable X. Okay, first one, we have sales and profit. So what is the relationship between sales and profit? So we expect that when we do more sales, we will get higher profit. So we expect that there will be a positive correlation. Okay, higher sales, higher profit means that positive correlation. Or between advertising expenditure and sales. So meaning to say that when we spend more advertising, our sales also will be increased. Okay, for example, nowadays, maybe you can hire or you pay, for example, Instagram influencer to promote your product. Means that you pay for the advertising. Then when they promote your product from their fans, for example, then your sales will be higher. Okay, so here, between sales and profit, so we will say that profit will depend on sales. So profit depends on sales. Profit is dependent variable Y and sales is independent variable X. For advertising expenditure and sales, so we would say that sales depends on advertising expenditure. So sales depend. So sales will be dependent variable Y and advertising expenditure is independent variable X. Okay, another example we have here is between production cost and production unit. So we will expect that the more unit we produce, the more cost we need to bear. Okay, so production units and production cost, which one is X, which one is Y. So we will say that cost will depend on how much we produce. So production cost is dependent variable Y and production unit is independent variable X. So later on, with example, I will give you some tips on how to identify correctly which one is Y and which one is X. Okay, now let's look at method to determine correlation. So in statistics, here I show you we have three methods. Okay, the first one using graphical method. So the graph that we can use to detect or to determine correlation is by using scatter diagram, or we call it as scatter plot. Okay, second and third one based on numerical method. Okay, so second one is Pearson product moment coefficient of correlation. So we use notation R. And the third one is Spearman's rank coefficient of correlation, RS. So S here to represent Spearman. So Spearman is the name of a statistician. Pearson also the name of a statistician. So for Pearson, we use for quantitative variable. For example, if you have two quantitative variables, example just now, sales and profit. So both are quantitative variable. So how to determine correlation between profit and sales, so we can use Pearson product moment coefficient of correlation. So we also have qualitative variable. For example, we have a grade of students. So grade of students, for example, we have A, B, C, D, E, and so forth. So how to determine the correlation? So maybe we can use Spearman's rank coefficient of correlation. So for Spearman, it is for both qualitative and quantitative variable. Okay, note that in your syllabus, we only cover the first and second ones, scatter diagram and Pearson correlation. Okay, now let's move on the strength of correlation. So just now we said that in the definition, we need to know the strength of the correlation as well. Okay, strength here means that either it is perfect or strong or moderate or weak, or maybe there is no correlation at all between the two variables. Okay, here we must know that when we calculate coefficient of correlation, so the value must be between from -1 to +1. Okay, so if you get beyond this value, so means that there will be some mistake in your calculation. So remember, value of correlation must be from -1 to +1. Okay, when interpreting the value of correlation, the strength that I said just now, either perfect, strong, moderate, or weak, and the direction means that either it is a positive correlation or negative correlation. So the strength and the direction we must state. Okay, now look at rule of thumb in determining the strength. So this one is just rule of thumb. Maybe if you read on internet or if you refer other textbook, it will give you different rule of thumb. So here is the guideline that I use. Okay, let's say if you calculate coefficient of correlation, you get value R, you get exactly equal to 1. So means that you have perfect correlation. Perfect means that when, for example, when value x equal to 2, y also equals to 2. When x equal to 10, y also equals to 10. That is meant by perfect correlation. Or if you get value r between 0.8 but less than 1, we can say that it has a very strong correlation. Okay, so if you get positive, means that the direction will be positive. If you get negative, the direction will be negative. Or if you get between 0.6 to 0.8, we can say that it has strong correlation. Between 0.4 but less than 0.6, a moderate correlation. Between 0.2 but less than 0.4, a weak correlation. More than 0 but less than 0.2, we can say that it has a very weak correlation. And last one, if R exactly equal to 0, means that there is no correlation exists between the two variables. Okay, if you look at here, value R ranges from -1 to 1. So if you feel that it is very hard for you to remember this, so I give you hint here. No need to remember all this level. So you remember like this. So remember 0, no correlation. 1 means that perfect. So if you get positive, means that perfect positive correlation. If you get -1, means that perfect negative correlation. Okay, now remember your test mark or test score. Normally, we would say that if you score 80% and above, it will be good, right? That means that you will get A. So you just remember like this. If 0.8 and above, or you get -0.8 and below, means that is -0.8, -0.9. okay, you can conclude there is a strong correlation between the two variables. So it is not necessary, for me I don't mind, it is not necessary for you to state very strong or very weak and so forth. Okay, so you just remember from 0.8 and above, strong correlation. If it is positive, means that strong positive correlation. If you get negative, strong negative correlation. Okay, then if you get test mark, for example, 50% and above, 50% means that you already passed for that test, for example. So start from 50, we can say that it has a moderate correlation. Okay. Then below 50, so you can say that weak correlation. So that is the easiest way to remember the strength of correlation. Again, I repeat here, 0, no correlation, 1, perfect correlation, 0.8 and above, strong correlation, 0.5 but less than 0.8, moderate correlation, less than 0.5, weak correlation. Okay, so easy. Only three levels of strength that you need to remember: weak, moderate, and strong. If you get value R, for example, equal to 0.95, 0.99 or 0.98, means that 90% and above. If you want to conclude very strong correlation also, no problem. Okay. So for example here, how to interpret value R correlation. So we must take the strength and the direction. Direction means that either positive or negative. Strength either weak, moderate or strong. Okay, example. If R equal to 0 means that there is no linear relationship between x and y. Linear means that the variable is to the power of 1. So recall, if you have variable, for example, x squared plus 2x, so x squared plus 2x, in that equation, the highest power is 2, right? X squared. So that one is not linear. That one we call it as quadratic equation. So linear means that our variable is to the power of 1. For example, you have equation of 2x plus 3. Okay, so x is only to the power of 1. Okay, later I will explain more about linear using scatter diagram. Okay, if you get, for example here, R equal to positive 1, so we can conclude that there is a perfect positive linear relationship between x and y. Okay, but normally in real life, it is very hard to get perfect data. Okay, another example I give you here, R equal to 0.83. So we can conclude that there is a very strong positive linear relationship between x and y. So if you just put there is a strong positive linear relationship between x and y also, no problem. I still accept. Okay, another example. R equal to negative 0.53. So just now I said if below than 50% or below than 0.5, we can say that, above 0.5, we can say it has a moderate relationship. So here, negative 0.53, there is a moderate negative linear relationship between x and y. If R equal to negative 0.13, there is a very weak negative relationship between x and y. If you just put there is a weak negative linear relationship between x and y also, should be no problem. So the most important thing is either it is weak, moderate or strong. Okay, now let's look at scatter diagram, which is a graphical method that we can use in detecting the relationship between two variables or the correlation that exists between the two variables. So this is a graphical method. So after this, I will show you on how to plot scatter diagram based on independent variable x and dependent variable y. So how we detect the relationship is based on the pattern of their intersecting points from the scatter plot. Okay, if the diagram, the scatter plot does not show any pattern or is randomly scattered, then we can conclude the two variables do not have relationship. Okay, here we have some examples. Okay, the first one, for example, like this. Okay, we can see that the direction is to the right. So if the direction is to the right like this, so means that it has a positive correlation. So if you can see pattern from the scatter plot, something like this, so we can say that it has a perfect positive correlation. So recall what is meant by linear just now. So linear, if you use scatter plot, it will form a pattern of straight line like this. Okay. So this one also we can see a pattern of straight line. This one also we can see a pattern of straight line. So if to the right, it is positively correlated. Okay, how about the strength? Either strong, weak, or moderate. Okay, like this is perfect. Okay, you look at the data points. If the data points falls closely among themselves, so we can say that it has a strong positive correlation. However, if we have something like this, we can see that the data points falls slightly far from each other, so we can say that it has a weak positive correlation. Okay, this one, the direction is to the left, means that it has a perfect negative correlation. So this one again, you look at the data points, it falls closely to each other, so we can say that it has a strong negative correlation. This one, the data points falls a bit far from each other, then we can conclude it has a weak negative correlation. Okay, now let's look at this scatter plot. Okay, 1, 2, 3, 4, 5, 6. So from these 6 plots, we can see a pattern of straight line. This 3 is to the right, this 3 is to the left. However, for this one, all the data points, we can see that they are scattered randomly. So if scattered randomly, so means that we can conclude there is no correlation exists between the two variables. Okay, after this we will use a data on how to construct a scatter plot. Okay, here I'm going to show you on how to draw a scatter plot. So if you look at here, we have data about a student is investigating the relationship between the percentage of dark cocoa solids in a chocolate and its price. So here the two quantitative variables are percentage of dark cocoa in a chocolate and the price. So we will expect that the more percentage of the dark chocolate, the higher will be the price. So the expected relationship will be positive. Okay, in determining which one is X, which one is Y, so it will be, so normally we would say that price will depends on how many percent of the cocoa contained in that chocolate. So price depends, so price will be Y dependent variable and the percentage of dark cocoa will be independent variable X. Okay, so how to plot scatter plot? So normally we would plot the pair values, means that value X and Y simultaneously. So here we have 8 grains of chocolate. So how to plot scatter plot using this data. Okay, first you prepare a scale for x and y axis as usual. So x axis here will be our independent variable x, and y axis here will be our dependent variable y. So y just now is price and x is the percentage of dark cocoa. So about the scale, again you look at lowest and highest value. So for variable x, I use scale of 20, so it's up to you. You can use any scale that suitable. So for y, I use scale of 50. Okay, x axis, so I use 10 boxes for 20 units. So if 10 boxes for 20 units means that for one small box here will be equivalent to 2 units. Okay, so 20 divided by 10, you get 2. So one small box here will represent 2 units. Okay, y-axis, I use scale of 50 where 10 boxes equal to 50 units. So meaning to say that one small box here represents 5 units. So 50 divided by 10, you will get 5. So 1 to 5 means that one box equivalent to 5 units. So how to plot? Very easy. Okay, look at brand A, the first data. When x equal to 10, the price or the y is 35. So you look at x and y simultaneously. So when x equal to 10, so my 10 is here. So x equal to 10, so this is x-axis. So y is 35. So where is 35? So here is 25, 30, 35. So this is point x equal to 10, y equal to 35. Okay, next data, x20, y55. So x20, y55. So 50, 55 here. Next, 30, 40. So 30 here, 40 will be here. 30, 40. Next, 35, 100. 35 will be, so 30, 32, 34, 36, so 35 somewhere around here, 35 and 100, so here. And then 40, 60, 40, 60, so here 60, 40, 60, 50, 90, 50, 90, so 90 is here, 60, 110, 60, 110, 110 is here, and last one is 70 and 130, 70, 130. So here 70, 130 will be 10, 20, 30 will be here. Okay, so that's how you plot value x and y simultaneously. Okay, now how to conclude the relationship that exists based on the scatter plot here. Okay, again, we need to state the direction and the strength. Okay, so if you look at here, we can see that the direction is to the right. So we can conclude that there is a positive correlation that exists between the price and percentage of dark cocoa contained in that chocolate. Okay, how about the strength? Either it is strong, moderate, or weak. So since we have only 8 data, so maybe it is very hard for us to conclude is it strong or moderate or weak because we have few data only. If we have more data, it will be easier for us to conclude on the strength. However, here we can say that okay, so we can conclude that based on the scatter plot, we can conclude that there is a linear see a pattern of straight line. And the direction to the right means that positive. There is a linear positive. So we must take the direction and the strength. Okay, so just now we can say that there is a moderate. Okay, based on the scatter plot, we can conclude that there is a linear moderate positive, so strength and direction relationship between percentage of dark cocoa contained in a chocolate and its price. Based on the scatter plot, we can conclude that there is a linear moderate positive relationship between percentage of dark cocoa contained in a chocolate and its price. So meaning to say that the more dark cocoa in that chocolate, the higher or more expensive will be the price. So that is meant by positive relationship. So again, remember, when we want to conclude about the relationship, we must take the strength, okay, so the strength here, and the direction. Okay, later on, we will see, based on numerical method, on how to determine the correlation. So this is based on graphical method. So in order to ensure the strength, is it moderate? So we will use Pearson coefficient of correlation.